Distance and displacement. Okay, so distance and displacement, they are both physical quantities. Distance is a scalar, whereas displacement is a vector. Let me give you a background of scalar and vector. Scalar is any physical quantity that does not have a direction, whereas vector has a direction. Scalar has both magnitude and a unit. Vector also has a magnitude and a unit. Okay, so distance. What's the definition of a distance? So distance is basically the length of the path covered between any 2 points. Its SI unit is meter. So if let's say we have these 2 points A and B, so any length of path, any path that is covered, the blue path, if I have some particle and it travels from A to B following the blue path, following the blue path, then the length of this blue path would be its distance. If it travels you following the purple path, then the length of this purple path would be the distance. If it travels using the green path, then the length of the green path would be its distance. If it travels using the red path, then the length of the red path will be its distance. Whereas displacement, on the other hand, is a vector. As you guys know, it has a position with respect to a starting point. It represents the position of the particle with respect to the starting point. It basically is a direction. It is the shortest possible directed distance between any 2 points. So if we talk about A and B, the shortest possible distance is this red line, and it's if it has to represent the displacement, then it has to be represented with respect to a certain point. If I take A as my starting point, so the shortest possible distance from A would be the displacement of B. If we talk about the displacement of B from A, this red line would be the displacement of B from A. So the shortest possible distance with respect to a starting point is the displacement. Its unit is also meter. SI unit is meter. It shows the distance of a body from its original starting point only. Okay, so the shortest possible distance from the starting point is the displacement, whereas the length of any path that is covered between 2 points by the particle or by the body is the distance. Okay. uh, One more important thing, when the body it returns back from B to A, then with respect to A, its displacement becomes 0 because the distance from A at A is 0. So whenever a body returns to its original point, original starting position, its displacement becomes 0, but its distance is not 0. Why is the distance not 0? Because when the body was moving forward, in this direction, and when it returned back, it did cover some distance. The path that it followed going forward and the path that it followed coming back, we are going to add their lengths to find the distance. But displacement, since it shows just the distance from the starting point, it becomes 0 because at the starting point the distance from the starting point is 0. But not the distance, the displacement from the starting point is 0, but the distance has been covered. So if the upper arrow has a length x, the downward arrow also has a length x. By the arrow I mean the distance that it has covered. Going forward, the length of this path is x, and coming back, the length of this path is also x. So the total distance in this case would become x plus x, which would be 2x. Okay, but over here at point A, the displacement would become 0 with respect to the point A being the starting point. Okay, now let's look at the graphs. This point over here that I just explained is important with respect to MCQs because there have been some past year paper questions on this. Distance can be greater than or equal to displacement, but can never be less than the displacement. The distance, if the particle has followed the red path, the distance and displacement are going to be equal. If the particle has followed any other path than the red path, any path other than the red path, it would have traveled a greater distance compared to the displacement. So distance is always greater than or equal to the displacement, but can never be less than the displacement, because displacement is the least possible distance between the 2 points. This is also an important point. Remember it. Now let's look at these diagrams. Okay, if I have a trolley which is moving with a speed v, a constant speed v, and after some time t, in between the 2 points A and B, after some time t, this trolley moves to the point B. The distance that it covers till B is s. If I were to draw, and I have represented it over here, the s is the distance and A and B are the 2 points. Velocity is constant. If I were to draw a graph of distance against time, s represents the distance and m is its meter, its unit, s/m, and t represents the time, s is the seconds, the unit of time. Okay, so as time increases from 0, let's say when the trolley reached at point A, we started the stopwatch, and so the stopwatch started from the time 0, and as the time increased, the trolley covered some distance, and after some time t, we stopped the stopwatch at the point B. So the distance covered at that point was s. So as the time increases, the distance covered also increases. As the time increases, distance covered also increases. So this is the type of graph that we are gonna get. Okay. Now there are a few properties of the graph that we need to know. What does the gradient of the graph represent? The gradient or the slope of the graph represents the speed in the distance time graphs, and the gradient of displacement time graphs represents velocity. In this case, the velocity was constant, right? So the graph has a constant gradient. This is the reason why it has a constant gradient, because the velocity is constant. So since the velocity represents the gradient of this graph, so the graph is going to be a straight line passing through the origin with a constant gradient. So at time 0, okay, an MCQ that came recently, at time 0, what's the velocity of this cart? Looking at this, the origin, it just seems as if the trolley is at rest, but this is not true. This is not true because in this graph, the y-axis does not represent the velocity. The y-axis represents the displacement. It's the gradient that represents the velocity, and at the point 0, at this point as well, the graph, this trolley has some velocity v, which is equal to this gradient of the graph, because the gradient is still constant. Okay, so this is an MCQ that came at time 0. The velocity, the trolley is not at rest. The trolley is not at rest because the gradient of the graph is not 0 at the point 0. Okay, now let's move forward. In between the 2 points A and B, a trolley, in this first case, the trolley moved a distance s in time t, so this was its graph with a constant gradient because of the constant velocity. After the time t, it covered a distance s. So basically covered a distance s after some time t. Okay, now let's look at the second diagram. From A to B, it covers a distance s1. Then from B, it returns to point C and covers a distance s2. Okay, so it has, the journey is in two parts, from A to B and then B to C. From A to B, the distance is s1 and the displacement is also s1, because the shortest possible distance between A and B is s1, so displacement is s1, and in this case there is no other path that the particle followed. It followed the green path from A to B.